How to calculate the confidence interval of given data using Google Sheet. To do that, we have a data of tar, and let's find out the input, and there are two methods we are going to do it. Find out the n value equal to, you can just simply put count A, and you can select the array, close the bracket, and you're gonna get that value. So I'm gonna cancel this one because auto refill will not work here because we are gonna use a different formula. Standard deviation, again we are gonna do the same, and this is the standard deviation we got. Then confidence interval. Most of the statistical decision are made using 95 percentage confident, unless you specify, customer specified 99 and so on, right? 95 percentage is commonly acceptable. That means 95 percentage can be written as 0.95, and that means alpha will be 1 minus 0.95. That means 0.95, that is 1.05, that is 5 percentage is your alpha. That okay, let's find out. There are two methods we are going to do it. One is standard error of mean. Standard error of mean equal to standard deviation divided by square root of n. This is the n value. Okay, this is what is standard error of mean. And then margin of error. Margin of error is based on the values. The margin of error will change, right? For example, let's say if you are talking about 95 percentage, that means 1.96 is the value. And for that, you can also go through that also as well. For example, let me take that link to you. It will be easy for you to understand it. It is also given in this here also as well. If it is 95 percentage, 1.96, if it is 90, 1.65, and so on and so forth. And it is also given in the survey monkey also as well. Okay, let's go back. Okay, let's find out that the confidence interval at one end. So the formula is mean. So we have to find out the mean first. So let's say mean. So this is the process mean, right? So this coming from the parameter, right? Okay, average, and you're gonna take it all the way here. Okay, so the mean also we found. So let's calculate further now. Equal to mean, let's say plus, and this value into z into standard error of mean. Okay, that means 27. Similarly, maybe I'll make it only no decimal. Maybe I'll similarly you can find it the same thing. Mean, your mean is here, minus z times standard error of mean. This is again like, that means that tar will change, will the with the 95 percentage confident, we can tell the torque value will be between 21 to 27, and considering the mean value is 24 with the 95 percentage confidence. Okay, and similarly method 2 is quite straightforward, very straightforward, and you can directly get it here. Confidence alpha, we know alpha value 0.05, comma, standard deviation. Standard deviation also we know, comma, and then population size. And we have taken 24, right? Okay, give enter. So this is the value we have got. Now from that, the confidence interval, you can just add it. So mean plus this one, you will get, I'll make it no decimal. So 27, exactly the same thing. Mean minus this value will be 20, right? That means we can 95 percentage confident we can tell that the confidence, the value will be 21 and 27, right? Let's say the project what we have, we don't have, we don't need to have 95 percentage confidence. Let's say we are good with, even if it is there as, let's say 90 percentage, right? 90 percentage is good enough. If it is 90 percentage, the value will be 1.65, right? If it is 90 percentage. Similarly, if you wanted to have 99 percentage, that means 2.58. Similarly, let's do the same thing. Let's go back, and I'm going to, this is 95 percentage confidence. Let's do it for 90 percentage confidence. Again, all the value will remain same, but only this value will change. That we will do. So let's do it one more time. So n value, that is, we know that is a 24. I'm going to quickly type it 24, and standard error and a standard deviation, I'm going to copy paste the same. Or what I can do, I can just quickly do the standard deviations. Okay, and auto fill, I'm going to cancel. Okay, same value. So confidence interval. Now we are talking about only 90 percentage confident, right? When you say 90 percentage confidence, we're going to put only 9. So the alpha will be 1 minus this value. So that means 10 percentage. And mean is going to be same. We'll take the average. Okay. So we got this average value also as well. Similarly, standard error of mean, that is the same like D3. D3 our standard deviation, and now we got that standard error of mean also as well. And margin of error. Margin of error equal to z value. We know that if it's 90 percentage, is going to be 1.65. This is based on the table. So now we can easily calculate the first and the other end. Confidence interval, right, equal to the same similar value, 26. And similarly, you can also calculate this also as well, right? Almost the similar value we are getting it. For these two, we are going to getting the similar value also as well. Okay. Standard error of mean. Yes. So this is the same value we are getting it. Let me do it one more time manually. So standard error, standard I mean mean plus z value times you have value of times, and then standard deviation, standard error of mean, right? So this is the same value we are getting it. This is good. D6, D10, and okay. And then if you wanted to do directly also, you will get the same value, right? How we should do? So we can just put it like confidence interval. Just put like confidence. You will, sorry, confidence equal to confidence. Okay, alpha. In our case, this is the alpha value, comma, standard deviation. Will go to standard deviation, comma, and you have, then you have a sample. This is your sample. Almost similar value, right? And then if you wanted to calculate this, the method 2 is quite straightforward, right? Mean plus confidence interval, mean minus confidence interval. So you get this one. That means we can say 21 to 26.94 it will go. Similarly, what if we are having low confidence? Let's say, no, further more we can go to it. Let's say 99% confidence we can go, right? And again, once again, it is gonna be 24 and it gonna be 8.40, and the confidence interval will be 99, right? So 99, that means the alpha will be 0.01 and the mean value is gonna be same 24125. I mean, otherwise you can just deploy the formula also as well. And a standard error of mean equal to the same formula. So the n divided standard deviation, that is E3, divided by square root of n. So you can just give the same value. So you can see slight difference it has become. Now let's find out the margin of error. Margin of error, we know the formula, and you can, what you can do, if it is 1.65, it is 90%. 99 will give you 2.58, right? And then similarly we can calculate this also as well. That means if you wanted to have at one end, again you take your mean value plus this standard error of mean into margin of error. You got one end of the confidence interval. Let's find out the other end. So all we have to do is this one. So that means 19 to, maybe I'll make it no decimal, so it will be easy to explain. So that means, with if you are having 99% confidence, that means we know that the torque value will be 20 to 29 with a 99% confidence. Okay. Similarly, method 2 is quite straightforward. So you can, all you can do is the confidence. Okay. When you say confidence, it is picking up E5, that is your alpha, E3, that is your standard deviation, E2, that is your same value, that is n. So I'm gonna give OK. And similarly, you can find out this plus your mean and this. So that means the same value we are getting it. Okay. So you can see that the value, if we are 99%, that means the value will be between 20 to 29. The torque value will be 20 to 29. And then you can do the similar one. Let's say if you wanted to have that 80, right? So what will be that? If it is 80, we know that Z value will be 1.28. Find out that value and let us know in the comments. Thank you so much.